Number 56. If the pressure due to the red spheres in the molecular art is 480 millimeters of mercury, so here's the picture, what is the pressure due to the blue spheres? And what is the total pressure? So we're given a picture and we can count how many particles there are. So we have information about the number of particles, and we're also asked about the pressure. So pressures and the number of particles, here is the gas law that we're going to need. This can be deduced from the ideal gas law. Assuming the volume and temperature are constant, you can move those to the other side of the equation, and you're left with P over N equals a constant. If that doesn't make sense, take my word for it, or study in the book. All of the gas laws can be deduced from the ideal gas law, and when you're dealing with pressure in moles, here is the corresponding gas law. P1 over N1 equals P2 over N2. So we can count the number of particles for gas 1 and gas 2, if you want to say the red one is number 1 and the blue is number 2, or vice versa. I think I did it vice versa. There are 5 blue particles, and we're looking for the pressure of the blue gas, and there are 6 red particles, and we're told the pressure of the red gas. So here is the information, and we can plug in this information into this equation. The 5 particles goes in as N1, and we're looking for P1, and the 6 particles goes in as N2, and we're told P2. And so we're solving for P1. Here we go, and here it is right here. So 5 and 6, we're not really told, are these actual molecules or do these represent moles, but we're not really sure. The number of particles that we see is going to be proportional to the number of moles, so we'll just leave the units off. Whatever they are, they would cancel anyway, so it's just 5 over 6. And so you got 480 millimeters of mercury times 5 over 6 gives you 400 millimeters of mercury, and that's the pressure of P1. It makes sense that the pressure of P1 is a little bit smaller than the pressure of P2 because you got a little bit less blue particles versus red ones. So they'll exert a little bit less pressure. Now the total pressure we can get using Dalton's law of partial pressures. The total pressure is simply the sum of the 2 pressures from the blue and the red gases. You got, the 480 plus the 400. I think the 480 goes with the P2, the red gas, and the 400 goes with the P1, and so that adds up to 880 millimeters of mercury.